All right, so looking at this magic square question, I'm not gonna go, this isn't a normal routine where I would go through a quiz like this. It's only because I wanna make sure that you guys feel a little bit better about this one, but assume that, don't always assume that if you see a question on your quiz that you've never seen before, that, oh, Andrew's gonna go over it in class and then he's gonna give us another attempt. That's not gonna always happen. In fact, it might happen one more time over the course of this semester, and that's in chapter 8. So, yes?
Without giving some other attempt, would you sometimes just go over it?
Yeah, I'll go over it. Yeah, no problem. Yeah. So, but if it's something like chapter 8, there are some questions in there that are a little bit brutal. So other times I might pull the quiz up ahead of time and go through the quiz with you beforehand. That might happen once or twice over the course of the semester. But just assume that the normal routine is gonna occur. I gotta get the quiz done, I got 2 attempts, and it's due by the time we start class. So there it is. With that said, let's go through this magic square question and see if we can understand. It says a magic square is a square array of numbers arranged so that the numbers in all rows and all columns and the 2 diagonals have the same sum. So let's stop right there to understand what's going on. What they're saying is that a magic square, this item right here, if I add everything this way if you want to look at it that way, and this way, and then if I add it along the diagonal this way and along the diagonal this way, they should all equal the same thing. You guys following me? Okay, so a magic square is one where if you add left, right, top, down, and the 2 diagonals, everything should equal the same, okay? And so what they want you to do is fill in the missing numbers, A, B, C, D, and E. Now, what you want to do is go, okay, well, I have 2 pieces of key information. I know 1, that everything should add up to be the same thing, and then number 2, they've given me numbers as hints to hopefully help me get to that. Well, go find, here's your trick, go find the one column, row, diagonal where all 3 are filled in first. Well, which one is that? For me, in my problem, it's this one right here. I don't see any columns that give me everything. I don't see any rows that give me everything, but I do have a diagonal that gives me everything. If I know this, what's that gonna tell me? It's gonna tell me what all the others need to be added up to. Are you guys following me? Okay, and so that's your key hint there. Let's go do it real quick. So 8 and 16 is 24, 24 and 24 is 48 for my problem. Okay, so along the diagonal, it's 48. And that is a very important number because what does that say? It says that every row, every column, and the other diagonal needs to equal 48. So what's your next thought process here? Your next thought process is, well, is there another one that has 3 in a row that I can just add? Well, no. Okay, so I'm done with those. Now go look for one that has 2 in the row, column, or diagonal. And why is that important? Because if you already know what it's supposed to equal, and you have 2 of the 3 pieces filled in already, then a simple subtraction will get you the 3rd missing piece. Got it? Okay. So which one works? Well, this one, 8, 16, and A, there's 2 out of the 3. 16, 16D, that's 2 out of the 3. Are you guys following me? So I can do either of those, both of those, and that's what's that gonna do for me? Not only is it gonna complete the A and the D, but once I know those 2, it's gonna start letting the dominoes fall for the rest of them. You guys following now? So if you struggle with that, hopefully that opens up your eyes to how to work that. So let's do this one, 8, 8, and 16. So I know 8 and 16 is what? 24, right? So currently, the sum is 24, or I can kind of write it off to the side right here. So it's 24, but that's not the answer, is it?
No.
The answer is the difference between the 24, and we know that it's supposed to be 48, so of course this row is 24, and so not the row is 24, but what? A is 24. Make sense? So we know the row is 48. We know the two of the three components, their sum is 24, which means that missing piece has to be 24. Okay, so now we've got another one done. Let's go look at this one. Why am I looking at D? Because again, I have 2 out of the 3 pieces there. And so this diagonal with D in it, I can solve that. If I know that 16 and 16 are 32, and I know that this diagonal is supposed to be 48, then by subtracting 32 from 48, I will find out that D is 16. And now I'm almost done. Why am I almost done? I'm almost done because now this column has 2 out of the 3. This row has 2 out of the 3. This one I can't do right yet because it's 2 that are missing. But once I know this and once I know this, or once I know this, I can easily get that one. Process of elimination, really, right? Okay, logic and understanding the characteristics of this magic square. So it doesn't really matter which one you do. I'm going to do, say, this one. Okay, so I'm going to do the row that has D in it. And I know that 16 and 24 makes 40. We know that that row is supposed to sum to 48, which tells us that E has to be 8. And I hope you guys are starting to get it now and working ahead of me, okay? And then now, well, actually I could do C, couldn't I? I could figure out C by doing these two and doing the column. I could figure out B by doing the column. There's a couple ways you can do it, right? Or I could figure out B and then do the row. So I hope you guys are seeing that the deeper you get into it, once you start finding out more, it opens up options for how you can figure out the remaining ones. So what I'm going to do is, since I really haven't done any columns yet, I'll go do this column. And so I'm going to go figure out B. I know that 8 and 16 make 24. I know that column is supposed to equal 48. And so that leaves me with 24 as the value for B. So now, the final piece, C, and again, like I said, this is in no particular order. As you heard earlier, I had choices, right? You don't have to go, okay, all right, Andrew did this diagonal first, then he did the D, and then he did the A, then he did the E, then he did the B. No. Take a step back and understand that I'm solving this by process of elimination. I need to find first a row, column, or diagonal that has 3. Then I'm going to find a row, column, diagonal that has 2, or do the ones that have 2. Then I'll find the one that has 1, and then, or whatever's left over by default. Okay, so this C right here is flexible. I can figure out what C is by working the row. I can figure out C by working this column. It's really up to you, it doesn't matter. Just to change things up, I'll do column again. So we've only done one column, we've done some diagonals, some rows, whatever. It doesn't really make a difference. You'll get the same answer. So 24 and 16 is 40. We know that column's supposed to equal 48. And so that tells us that C is 8. And you would have gotten the same thing. Take a look here. 24 and 16 is 40. 48 minus 40 is that same 8, whether you did it by row or by column. Make sense now? Hopefully you guys feel good about that. All right. And there it is. Okay? So, just in time. Let's move on to that other question that dealt with, well, I guess I'll do the latter one. I know you guys can do it or should be able to do it, but I'll just do it since I'm here. But don't assume this is normal. All right, let's take a look. So Kathy stood on the middle rung of a ladder. So in order to do this problem, I was telling the student that emailed me, I said, hey, draw a picture and see if you can solve this. So I'm going to draw a picture of what's going on here, all right? So I'm going to draw this ladder, okay? I'm going to call this the middle rung. Following me? Okay? So I'm done with this first sentence. I've used the information to start building my picture of what my ladder looks like, or how many rungs are on my ladder. She climbed up 2 rungs. That means she went up by 2. Following me? Okay. She moved down 5 rungs. So a lot of people, for some reason, have a little bit of an issue counting. I mean, in all seriousness, they really do. So they go, do I count the first one? No, sorry, here we go. 1, 2, 3, 4, 5. You guys following me? Okay. So here's the middle rung, the key one right here. Up 2, 1, 2, down 5. 1, 2, 3, 4, 5. With me? Okay. So that one's done. Okay, she moved down 5 rungs and then climbed up 6. Okay, so here's where Kathy's at right now. 1, 2, 3, 4, 5. There's the 6. She's currently here. You see how we're building that ladder right now? And so now, then she climbed up the remaining 4 rungs. So she's here, and they're saying that there's 4 more to get to the top. So there's 1, 2, 3, 4 to the top. So here's the top of the ladder. How many rungs are there in the whole ladder? The wrong way to do this is to just add what's on your paper right now, right? Because we know that this one's the middle. The middle's not up here. That means that we need to fill in whatever's down here based on our knowledge of what's on the top. You guys following? Okay? So don't be just counting this and dumping your answer there. That's not correct. So what we need to do is, if I know how many rungs are above the middle, now that I know it, I can count that up and make sure that's the same amount below, and then the total amount, that's how many rungs are in my ladder. Okay? So here's the middle. 1, 2, 3, 4, 5, 6, 7. I'm not adding 7 to what's there already. I'm making sure that below the middle, there should be a total of 7. I already have 3, 4, 5, 6, and there's 7. Make sense? Okay? And so now, to answer the question, there's 7 above, there's 7 below. Are there 14?
No.
No. Plus 1 more for the middle, so you have a total of 15 rungs on this ladder. Make sense? If you want to label it, there's the bottom, right? So, any questions about that? I hope that helps drawing the picture, working one step at a time, and understanding the framework. Hopefully now, those 2 questions are down. All right? Okay, so garage, I'm going to do that one, you got that. I only have one more question to do here, and that is the friends one. The friends one. That was that one. All right. So let's do the one that pissed everybody off. Or you just didn't even do, right? So let's take a look here. So when you see it, what's going to happen is some of you are going to be like, oh, that totally makes sense now. And others of you are going to have to digest it for a little bit and work on it a little bit more and process it. Okay, that's really normal because this is a little bit of a tricky question. So some of you are going to be, okay, I get it, just like the rungs on the ladder or the other problem. Others of you are going to be like, okay, I need to sit down with this a little bit more. And that's fine. You have quite a bit of time to do that. Just make sure, I'd love to see you get this problem because it is going to show up on your test as well. So, with that said, 5 friends, A, B, C, D, and E, agreed to share the expenses of a surprise birthday party equally. If A spent $36, B spent $17, C spent $18, D spent $35, and E spent $37, who owes money after the party and how much do they owe? Okay, so let's first write this down of what each person spent. So A is 36, B is 17, C is 18, D is 35, and E is 37. Right? Okay, so step 1 is just make sure you've got the amounts written down for what each person contributed. And one way to work through this problem is to think about a scenario. Think about yourself in the scenario. You're with 4 other people, and you guys are supposed to split the cost of this party, and at the time, everybody just dumps in whatever money they have. Well, what we're trying to do in the big picture is figure out, okay, we all dumped money in, who put too much money in, who put too little money in, and we need to make sure that everybody gets taken care of so that it's even, because we've all agreed that we don't want anybody to be taken advantage of, and at the same time, we don't want anybody to underpay, okay? And that's the scenario of what's going on, okay? Who owes money after the party and how much do they owe? So let's stop right there. So, question for you, if we add all this up, will we know the total cost of the party? Yes, because everybody dumped their money in and that paid for the party. Make sense? So, really, step one is, yeah, lay out what everybody paid. But step two, the real big kind of important piece that you have to understand is that you got to add all that up to figure out what did everybody, how much was the cost of the party. Because once we know the cost of the party, and once we know how many people we're supposed to pay for the party, we can do what? We can divide it and figure out the equal amount that everybody was supposed to pay. Now you're starting to see it, okay? So by adding all this up, that's the key piece to get started. 6, 7, 13, 21, 26, 33. What was it?
143.
Excellent. Thank you. That saved me time. All of us.
28, 26.
Very good. So we're going to divide that by 5.
28.6.
Thank you. So $28.60 is an important number. That's not the answer, is it? That's just what everybody was supposed to pay equally, right? So it's important because to note that I don't know if everybody's problem is going to have 5 people. I think usually it does for this one. But if for some reason your problem has 4, 6, whatever, you need to make sure that number changes, right? Don't be assuming that it's 5. We're only dividing by 5 because there's 5 people sharing the cost of this party. And this $28.60 means that if we were to share it equally, everybody needs to pay $28.60. All right, so now we can easily answer, right? Part A now, or part 1. So who owes money? So did A overpay?
Yes.
Overpaid. B underpaid. So B owes, right? C underpaid. C owes. D overpaid. They need to get, I guess, reimbursed, right? And then E overpaid, reimbursed. Agreed? Okay? So who owes money?
B and C.
B and C. Okay? Now, I can't verify this because I'm actually sitting on the quiz, right? But I'm just kind of go through it, right? So friends, B and C owe money. Let's go through this. How much do they owe? So notice how it says type 0 if the person does not owe any money. Who's going to get 0? Exactly. So A, D, and E are going to get zeroed out. So I'll just zero those guys out right now, or gals, whatever. D and E owe 0, and we can go figure out B and C. How do we figure out how much B and C owe? Yeah, just subtract it, right? Take 2860, subtract 17, 2860, subtract 18. What's that going to be?
1160 for B.
1160 for B. And what? 1060 for C?
Yes.
Okay, so there it is. And I hope now you guys are starting to see it, right? What was the key piece that everybody who struggled with this problem kind of missed is that add everything up, divide by that, and really understand the concept from your perspective. If you were in the same scenario, how would you do it? And this happens all the time, right? Okay, to whom is money owed? So which ones now need to be repaid? A, D, right? So A, D, and E are not, they don't owe anything, but they are owed money, right? So B and C owes, A, D, and E are owed. So there it is, A, D, and E. All right, how much are they owed? And so type 0 if they are not. So in this case, B and C are zeroed out. Does that make sense, everybody? You guys seeing what I'm doing here? Because B and C owe money, in the previous scenario we accounted for them. In this one, where we're discussing who is owed money, B and C are zeroed out because they aren't owed anything. So of course, how would we figure out how much A, D, and E are owed? Subtract again, right? But in this case, you take your 36, subtract 2860, right? So somebody tell me what that is.
740.
740. Good.
And the next one is 640.
Thank
And the
you.
last one is 840.
What was the last one?
840.
Thank you. And there it is. So you would type those in there. 740, 640, 840, and then there's that part, and then there's a little bit extra. There are several ways for the friends to exchange money, but what is always true about the money the friends owe and the amount owed to the other friends? Let's take a look at this. That's a little bit of an odd question. So one more time, there are several ways for the friends to exchange money, but what is always true about the money the friends owe and the amount owed to the other friends? The total amounts are equal. The total amount the friends owe is greater than the total amount owed to the other friends. The total amount the friends owe is less than the total amount owed to the other friends. Well, in order to figure this out, what can you do? Add these, right? So that's what? 2220. So what, in other words, what they're trying to do is ask you, what's the relationship between what is owed and what needs to be repaid, or what was paid and what needs to be repaid, right? And then you can add up 740, 640, and 840.
It's the same.
Is it the same? Okay. And so your answer to that would be that the total amounts are equal. Does that make sense, everybody? All right. And it should be that for all the questions, right? Because if you overpay and then it offsets that, then it should be equal. Anyway, so there's your quiz. You guys will get another attempt on it. Hopefully you guys can get 100 now that you have those 3 key problems addressed.